Okay, we're going to be on page 159 in your Agile Mind book. This is number 4. So let's go ahead and factor both the numerator and the denominator. This numerator, the first thing we need to do is actually check for a GCF. It does have one, so we're going to factor out a -2 first, and we're going to wind up with x squared plus 3x minus 4. So we're going to factor out that GCF first, and then we'll get it all the way over to its factor form using our x and box. So x and box. We're going to put our a times c, 1 times -4 gives us -4, with our b of +3. So our pair of numbers that multiply to be -4 and add to be +3 are going to be +4 and -1. Ooh, those colors are hard to see there. Let's try that again. +4 and -1. That's better. So we're going to have our -1x and our +4x. And then we're going to have our x squared from this equation. We're pulling from here. And our -4. So when we get this in factored form for our numerator, we're going to wind up with -2. That's our GCF times x plus 4 and x minus 1. So that's just the numerator. Now we need to go get that denominator. Let's draw a line over here, blocking that off. So same thing with this guy down here. We don't have a GCF, so we're just ready to go into our x and box. Oops. So our a times c, 1 times -3, is going to give us -3 on the top, and our b on the bottom is a +2. Pair of numbers that multiply to be -3 and add to be +2 are going to be +3 and -1. When we put those in our box, we're going to have 3x and -1x with our x squared. Oh, I don't know why it keeps doing that. There we go. X squared and our -3. We're going to put those in the box. Make my box a little bit bigger because it's getting a little chunky. Oh, I already did the box. Goodness me. We're going to put them in factor form. We're going to pull our factors. We have x and -1, x and +3. So we have x minus 1, x plus 3. And then we're going to look for our same things top and bottom that we can factor out. I have up here an x minus 1 and down here an x minus 1. So I can go ahead and cancel those out. That means we're going to have a whole wherever x minus 1 equals 0. Since it's canceling out, it's not affecting any of the other values because if it's anything other than 0, it cancels out. But if it's 0, it makes that denominator undefined. So therefore, we have to kind of account for that. So we're going to have a whole whenever x minus 1 equals 0 or when x equals 1. But we will deal with the rest of that later. So now let's get to our simplified form. And we have -2 times x plus 4 over x minus 3. Well, that's not our transformation form, so we've got a little bit more work to do. That means we're going to need to do our division. In order to do our long division, I need to simplify this top. So I'm going to multiply it back together to get -2x plus, I'm sorry, -8, -2 times that 4 as well, divided by x minus 3. And now we're ready to set up our long division. So we're going to take our numerator, -2x minus 8, and we're going to divide it by that denominator, that x minus 3. We're going to look for how many times does x go into -2x, and we're going to have -2, and then we're going to go ahead and say -2 times the whole factor is going to give us -2x plus 6. We are going to go ahead and subtract that whole piece. Draw the parentheses if you need to help remember that we're subtracting that 6 as well. So we have -2x minus -2x giving us 0 x's, and -8 minus 6 is going to give us -8 and then 6 further. I have made a mistake here. Oh wait, we'll cut around it. All right, so back to here. So let's write this in our simplified form. We're going to have our -2 times x plus 4 over x plus 3. We're going to need to do some long division now because I have an x in that numerator, which means I need to multiply this back out. So we're going to have our -2x minus 8 divided by x plus 3. And we're going to set it up in that long division that we've been using, where we take our numerator, -2x minus 8, and divide it by that denominator, x, oops, did the thing again, x plus 3. So we're going to say, how many times does x go into -2x? And that's -2. We're going to take that -2 and multiply it times the whole piece over here to get -2x minus 6. Then we're going to go ahead and subtract the whole bottom line from the top. So if you need to, use the parentheses. And we're going to get 0x's. -8 minus -6 is going to leave us with a -2. So we're ready to write this in our mixed number format, where we have our -2 as our whole number, then our fraction with our remainder of -2 over our denominator of x plus 3. We write this as a sum between the whole number and the fraction, and then we're ready to switch it back to its transformation form, where we have our f, oh goodness, why did it do the thing again? F of x, ooh, it's getting real cranky. Try it again. F of x, there we go, equals -2. Oh, it's doing like a lot. Let's see if we can get the same. -2 over x plus 3 plus -2 or -2. So there we go. We got our whole function rule in. We're going to write our horizontal asymptote. Remember your horizontal asymptote, that's your y equals k. So our k is the number added on the end. So we have a horizontal asymptote at y equals -2, which we can go ahead and sketch in on our graph. Y equals -2. It's going to be this horizontal line right here. And then our vertical asymptote is going to be at x equals h, or in this case, x equals, watch out for our opposite sign here, -3. So when x is stuck at -3, that's this guy way over here. So now what we're going to need to do is make our table so that we can plot this. I'm going to have to erase and give us a little bit more space over here. So let's erase this part so I can get my table in here. I'll go ahead and keep that long division so that we can use it later. Oh, we won't need to use it later, but so you can look at it if you need it. So let's go ahead and make our table with our parent function in the middle, x and y. Okay, I changed my mind. We're going to erase the whole division so we have the space. So make sure you have that written down. So our x's and y's, we're taking our parent function, that -2, -1, 0, 1, and 2, where we have our -1/2, -1, our undefined, which means this is part of our asymptote, +1, and +1/2. Then we're going to do our transformations. So let's go ahead and write out our a, h, and k. I know I already used our h and k, but we're going to write them again. So a, h, and k. A is the number on top, so a is -2. H is inside the function and has the opposite sign, so our h is -3. And our k is the number added on the end, it's -2. So when we're doing these transformations here, we're going to do x plus h. So in this case, we're going to add -3 and y times a plus k. So we're going to go times -2 plus -2. Go ahead and pause this video and then do these transformations. I'm going to go ahead and fill them in right now. We're going to have -5, -4, -3, -2, and -1. And we should wind up over here with -1, 0. Our asymptote doesn't change. Then we have -4 and -3. So we're going to go ahead and plot these points. I'm going to use black here. So we have -5, -1. So we're down here. -4, 0. -3 is our asymptote, which is right. We did great. -2, we have a point at -4. And -1, -3. So we can go ahead and connect these up right here like this to get our two swoops, our two curves. And normally that would be where we stop, except for the fact that we've got this hole. We need to come and deal with this hole, which means wherever x equals 1, we have a discontinuity, which means I'm going to zoom us in here. Whoops, a little too far. Zoom us in here to where x equals 1 is on our screen, nice and big. So what we can do is actually draw us in a hole. When x equals 1, wherever our line is, we're going to put an open circle. So I'm going to erase my whole curve. There we go. Oops. So we're going to go ahead. You can connect this back up. If you have a pencil, it should just erase a little bit right there. And you want to leave it with an open circle where x equals 1. Wherever our line winds up being, x equals 1 doesn't work. So we're going to put an open circle to show that that's where our hole is. If you really want to calculate your y value, you absolutely can plug in your x equals 1 into our transformation form. It'll give you a value, and that'll show you your y value for 1. That is a fine way to find your hole if you want to draw it before you connect your dots. But I think the easiest way is to actually just add it in after you've drawn your curves. So that is question 4 in your Agile Mind books.